And welcome everybody. Sorry for a bit of a late start, but you're very welcome to our live stream tonight. We will have three great talks upcoming for you. One about an outdoor pizza oven and barbecue created by Shane. Then we'll have a Kill the Dots remote LED game talk by myself, which I made a few months ago. And then we'll have a talk by Maya on building a large Core XY 3D printer. So if you've never heard for Tog, or if this is your first time coming along, you're very welcome. We are a hackerspace based in Dublin. We recently just moved into our new space out in Kylemore. This is our fourth space. We're very happy. It was touch and go for a while there, securing property, as you can imagine, in Dublin. But we overcame that, and we have a great new space that we're doing the fit out for at the moment. So our first talk of the evening will be Shane. So let me press some buttons here, click the magic transition button, and now Shane, everybody can see you on the screen, and you're ready to go. And I forgot to unmute Shane to tell him he's on the screen, but there you are, Shane. You're ready to go. Our audience is waiting.
Nice one, thanks, Jeff. Can you hear me okay?
I can hear you, yeah.
Okay, great. And so I'm sure Jeff has introduced me somewhat. My name is Shane Phelan. I've been a member of TOG I was trying to look in my emails to see how far they go back, but quite a long time. I'm an electronic engineer by background, but I'm a maker of anything that kind of is interesting. And for this talk today, it's a pizza oven and a barbecue. It intentionally was meant to be a barbecue, and then it escalated quite a lot as the project went on. So what I'll do is I'll set out the plan for how things were meant to look, and then it won't look really like that at the end, but at least you'll understand why that things evolved, and I'll try to explain them as I see them. So where this happened was in my parents' house, and this is what the starting point was. So the idea behind it was the person who owned the house before them had an idea of building this gigantic barbecue. I think his plan was to put it in on the right-hand side, and you can see it's actually kind of at least a meter and a half where the barbecue is meant to go. So I don't know how many hundreds of people he was planning on cooking for, but it was kind of a big job. And that sat like that for 6 or 7 years without anyone doing anything to it. It was not from the lack of want to do something to it, but no one really knew what way to approach it. So this year, given that we all had lots of spare time on our hands, I'm sure everybody used up that time in difficult. We came up with a plan to.
Sorry, Shane. We're just going to pause you there temporarily, and we're just going to have a quick look at your sound. You seem to be clipping out, so excuse me, our loyal audiences. But I will switch you all to a quick slideshow while I just fix Shane's sound. We'll be right back. And we are back. Thank you everyone for waiting. We have some sort of bandwidth limitations going on here that seem to affecting us. Shane, take us away again.
Sorry about that. So I don't know where it was breaking up, but essentially the plan was to build a barbecue and a pizza oven on top of that structure I was showing you earlier. The barbecue is inset underneath that kind of, it didn't really come out very well, that black screen on the left of the diagram, and there's a kind of a tray and box underneath that was meant to support the coals. After speaking to many people, the thickness of this concrete slab was a major variable. It started off at something like 8 inches, and over time, I think the final thickness was maybe somewhere like 80 millimeters. And I'm really, really glad it wasn't as thick as it was supposed to be originally, because it might look small, but a lot of concrete went into that. So, of course, we wanted to do a little bit more than just pour a concrete slab on top of the structure. We added an overhang to that. So originally it was 2x4s that kind of hold a melamine structure that allows for the overhang. You'll see on the left picture, it's kind of tradition, or it's actually recommended that you put glass bottles underneath in the pizza oven. And the logic behind that is the air helps somewhat for insulation. So if you were building your own pizza oven, some of them can stay warm for up to 60 hours. If you wanted to do that type of cooking, I would recommend putting in a lot more dilation than we did at this point. It's not something we were planning to do, but think about if you want to do multiple types of cooking after it's started to cool down. You'll see we use a cement mixer in this. We were originally not going to use one, and I can't do this unless you have a cement mixer if you're pouring a concrete slab, because it was hard enough putting the concrete into that. You'll see my dad already started pouring cement before I had the framing done, so that added to the stress of that day and framing done. And then we built around on that. So the concrete slab was poured. You'll see the little inlet I have for the barbecue, because the barbecue steel is actually set into that concrete there. Yeah, I didn't measure that, so it wasn't the right height, so that made screeding that concrete very difficult. But we got it done. The dome was constructed using an exercise ball. Mr. is particularly delighted with herself here, and you have to put cling film on top of it so the concrete doesn't stick. The concrete that's applied here is a mix of perlite, which is a kind of a type of volcanic rock that is used to insulate around chimney flues, and basically it can withstand very, very high temperatures, but is also somewhat porous, so it will insulate the inside of your oven and keep the heat in. And then this is where there's a good bit of maths here that you need to get right if you want your dome to fit on top of the slab, including the insulation and including the finish. So it's worth this a good few times to make sure you get your diameters correct. And I can share the measurements with people if they wanted to copy that. And this is where one of the first things changed. Initially, we were going to do a concrete perlite mix all the way out till the end, but decided that was because the bricks actually do look a little bit better. I think the Tog pizza oven was fully perlite, but given that this is in someone's house, you kind of have to look at it all the time. We figured we'd add bricks to the front of it, and that's what that smaller little arch is in that kind of middle picture. I highly recommend using something of a known size to keep the depth consistent as you build it. The base of the pizza oven is made of fire bricks. Forget the dimensions of these, but we used a mix of full-size fire brick, or ones called splits, which you kind of see up in the very top. You'll see that it's rotated at I'm not sure the angle, I'm going to say degrees. The idea being when you put your pizza peel into the oven to scoop out your pizza, you're not clipping your bricks, and that kind of is where the rotation came from. And you draw your inner diameter of where the dome is going to sit, cut all around the edges with every bit of face mask, eye and ear protection. You have very messy. It's not a nice process cutting those bricks. You number the outer, you take them all away, put sand underneath, and put the bricks back on top. When you have your bricks placed and your dome you need to mount the dome on top of the bricks. And it may or may not be, but really the important bit is that the inside lines up. And then you cover that dome with with ceramic insulation, but um, people have used rock wool and got pretty much identical results. It's intended to be able to withstand high temperatures, but given the thickness of concrete that's in that dome, I don't think crazy temperatures were penetrating through. So you use the chicken wire to cut in, and that gives you your kind of shape and a textured surface for your finish to adhere to at a later point. You use to fill in the interface between the fire bricks at the bottom and the dome at the top. So once we had that in place, this was the variable that came into it was the brickwork to make the arch, because that wasn't planned. The very very tight turn where it went from the arch. Let me see. How does that sound? I don't know. There's nothing else running. It's literally just this. Okay. Yeah. Okay. Yeah. Just let me know if it's flipping again. So the apologies. I don't really know what I can do to minimize the flipping. Do you want to just move on to the next speaker then? They might have more luck.
Apologies, folks. We're still having audio technical problems. So what we're going to do is we're going to jump ahead to the next speaker in a moment, and we'll work with Shane to see can we get some fix on his audio, or we might have to upload it to our YouTube channel at a later time. We can have Shane record the talk with much smoother, clearer audio and more enjoyable for all. So bear with us for a moment, please. Well, welcome back, everybody. Really sorry about those technical issues we were having there with Shane's talk. In the meantime, we'll try and fix them, or as I said, we might get Shane to upload, to record the video and upload it to our YouTube channel. If you have any questions on barbecues or for Shane, he will be trying to join us at the Q&A at the end. So still stick your questions into the chat, and we will hopefully be able to hear Shane when he comes back. So our next speaker is myself. I'll be talking about a project I made for Dublin Maker. So we'll get started now. Let me just load up my slide deck here, and away we go. So the project Dublin Maker was happening virtually this June. I really wanted to make something. So I tend to be good at coming up with these kind of big ideas. So the original idea for the project is there on the screen, where my great CAD drawing, you'll see on the right there, person jumping, and then some sort of LEDs that come down in front of them and showcase, have a jumping pattern, a bit like a dancing game as such. But when I end up organising the event itself, my thought or my belief of how much time I might have available to work on projects is a lot bigger in my head than the actual time I have available. So I had plenty of talk members come on board to give me a hand with this jumping game and somehow trying to make it remotely. But in the end, I had to cancel all those somewhat grand plans to make this jumping game and really scale it back to what I could make here at home for this event, and what I could do within a few weeks. So it went from a jumping game then pretty much to an LED game that I'm going to talk about now. So my first idea was to get the equipment together. So I knew I wanted to work with a kind of LED display and have some sort of game that goes over that. So my first port of call is Fast LED. So that's an Arduino library that allows you to fairly easy interact with lots of different types of LEDs, addressable LEDs, some NeoPixels, some kind of other brand names and other types of LEDs. And I knew that they had an ability to abstract the code a certain level into an array. So I installed that. It's great because I can, while I'm prototyping, I can throw it on an Arduino Uno, nice and small, easy to get going on. And if I need more processing power or stuff like that, it's fairly straightforward to upscale or change the microcontroller. So this is really what I started with, was a 16 by 16 LED array. It was nice and simple to keep on my desk. I could power it straightforward enough, all from a USB cable. I didn't need a separate power supply. So it was great. So over the course of 2 or 3 weekends, I came up with the code. The basic concept of the game is you have these red dots that are coming down the screen. They're surrounded by a green color, and then before they get to the end of the screen, you have to somehow swipe them off or kill them off the screen. Is the kind of basic gameplay I was going for. It became clear that a 16 by 16 array is unfortunately a little underwhelming as the size of the array. So I later went on to use a different LED panel, but this one was a great one to get started. So if I flick to the next slide, we should see the game loading on the screen. So this is where the kind of no user interaction. It was the array from the previous slide, but now I put a sheet of paper over it because I found while developing and testing all these LEDs, per eye set, but the per eyes taken out a hit, the LEDs tend to be a bit too bright for your normal usage, and all sorts of problems. So now a sheet of paper really acts as a great diffuser. So I kind of tried to make the code as kind of flexible as possible there, where I could enter in any size of LED array and it would work out smoothly. That I could move the code with minor alterations from one to another. So that was grand for testing. Then I went on, I added a quick there, I think it's a key shield or some type of Arduino add-on to the board there, and it was good just to add the kind of basic user interaction there. You can see in the video lines of white light going left and right and up. That's the kind of game mechanics to quote unquote kill the red dots and knock them off the screen as more appear on front of you. So it was grand for quick testing, getting an idea if the game would work. But then came the challenge of making it a remote game, so lots of people could play it and interact with it at Dublin Maker at this virtual event. So the tool I went to immediately is Romo TV. So it's mainly based around using a Raspberry Pi. So on the screen there, I took that screenshot I think yesterday, and someone has a telepresence robot set up in their chicken coop. And if you're lucky enough and watching the video long enough, you might see a chicken walk by. But it's a great platform that you install it on your Raspberry Pi. It gives you a simple enough interface to add buttons and interaction from the website, so you allow general users to interact with your robot, your telepresence. In this case, it was a chicken run, and in my case, it was an LED game. So it has plenty of kind of support for different kind of serial communications, lots of robotic hats for Raspberry Pi. It has kind of default support for. But yeah, it worked out great, and it was a great platform to pick. They had all the server infrastructure that I could host the game on and allow people to play it, so I didn't have to run my own server. So then it was fairly straightforward to then install that on an old Raspberry Pi I had lying around. So I didn't have a Pi cam at the time, so this very webcam I'm using, I stuck into the USB port, set up 2 LEDs, and it was fairly straightforward. I just kind of edited their sample hardware Python file, and I'm not very good at Python. I think I spent more time trying to work out the GPIO pin numbering scheme than actually writing the code. It was fairly straightforward that if A came in as a command, turn on one GPIO pin, and if B came in as a command, turn on a different one. So if I jump to the video, I think, yeah, I have here a demo where it's the website itself, and if you watch very closely, you'll see left and right being pressed on the website, and then you see the different LEDs turning on. That's the kind of interaction that I needed. That's all I needed for my game. I needed left, right, I needed straight up, and I wanted to start the game. So it's fairly straightforward. Now let me jump onto the next slide and talk a bit about how I got the Arduino that I was developing the code for on the LED panel, talking to the Raspberry Pi. So what I have is the left, right, up and start. I have them wired over to my Arduino on interrupt pins. So when one of the buttons is pressed on the website, it generates an interrupt on my Arduino, and that allows me to have kind of quick reacting times to user input to kind of lower the reaction time from when a user presses the button on the website to when I get it on my Arduino. So there's some technical issues to come over here. I guess it would have been handy to give you a circuit diagram, but pretty much a wire comes out of my Raspberry Pi. I go into a logic level shifter because the Raspberry Pi is talking on 3.3 volts logic level on its pins, and the Arduino I have here is running on 5 volts. So I needed a little logic shifter to handle that jumping of voltage between one and the other. Now, a big hassle that I got into while doing this was with the logic level shifter. So I didn't really read the documentation on the website. So I ordered it from Makeshop, which we'll hear from later on. But I didn't read the warning on the website about the use of pull-up resistors on it. And I ended up with getting intermittent signals through the logic shifter, and I was getting these floating pins. So I wasn't really getting that clean signal. So after actually reading the warning on the website and applying the right circuitry, I then had my Raspberry Pi communicating directly to my Arduino, shown there on the screen, and I was able to get the game up and running on the website. So I'll jump next to my next slide here. After this stage, I jumped straight forward onto the bigger LED array. So I went straight to a 32 by 32, so much bigger. I also changed Raspberry Pi. I was a bit worried that the refresh rate wasn't great on the Raspberry Pi. I think it was a 3 I was using. So one of the members in TOG loaned me a Raspberry Pi 4 that I could use. So I got the refresh rate up a bit faster on the website. And also I did try out using a Pi camera, but it couldn't compete to the webcam I'm using now in terms of refresh rate and auto handling the changes in brightness. So you'll be dark for 1 minute and then the LED display will come on, and that kind of flicker of light didn't really suit the Raspberry Pi camera very well. So also on the screen here you can see it's haphazardly set up in my room one weekend. That's some bed sheets just kind of strewn across it there to try and give some sort of darkness in the area where you're playing a game. And then at that point I then went off and got some beta testers, so some TOG members, friends and family, to log on to the website, play the game, give their suggestions and that sort of thing, to see what it lasts for. Last for the event was going to be several days, so I had to work out would the game be stable enough to then play over it. So based on how it just barely survived the testing that I mentioned just before, I decided to try and make the project a bit more robust. So in this one you can see I've got the upgraded Raspberry Pi. I have the wiring. I got myself a nice A4 sheet of laser ply. I got my favorite material, hot glue. I stuck it all down so it would be much more robust. A cable being pulled wouldn't pull all the different wires out, and I became a lot more confident of it lasting all throughout Dublin Maker. When I had glued it all to the board, it seemed like a quick and easy way to just add that security and robustness to the project to make it last. So as I mentioned earlier, it works best in a dark room because of the way the camera works. So in order to get, I needed this room here to do the live stream during Dublin Maker. So I decided to take over my living room. So I got my brother's help. We put up lots of plastic bags that are shown here in the picture. Coming in through there, that's a network cable into my Pi to get it online, but allowed us to cordon off half of the living room throughout the weekend of Dublin Maker, so people can play away the game. And when you're sitting in the other half of the room, you just see occasion flashes of lights as people play the game throughout the weekend, and it means I could just leave it off to one side. So here's a picture of the setup in the room. So I have a nice easel there to hold up the webcam at the right height. You can see there's the display out in front. So it's nice to hold the webcam just at the right position. Then have the Arduino, the Raspberry Pi, all those bits and pieces, and the fan going there. And just the laptop is there on the table just to do a bit of testing. So it meant I could put it through in the other half of the room, and then just let people play away for the weekend. So the next slide we're going to jump to is the actual gameplay. And I think this video is a couple of minutes long, but we won't watch all of it. So this is me playing the game. So it starts off that a number of red dots and their kind of green surrounding starts to come down the screen. And the idea is you have to try and clear them off the screen and not let them get to the bottom. And you can press left, right, or up. And you can see that it starts off quite big. So that yellow light there, you can clear a lot off the screen at one time. But as the more you clear, the less number of rows that white light gets to be. And then the game gets harder. And then the red dots also will start to move quicker. And more will appear on the screen. So some people seem to like the game. It certainly got a fair few plays over the weekend. So I've a couple of a list of improvements I certainly want to do to the project. Definitely add some sound effects. Some lots of pew pew noises or different sound effects to get going, to add a bit more interaction. Also, it doesn't have a scoreboard. You can't really find out how you're doing. You'll just notice there was a flash of light there. That's when one of the red dots got past the bottom of the screen, and you lose a life. But of course, there's no scoreboard. There's nothing else. It was a bit of a project, a rushed project, getting it ready for Dublin Maker and have something for people to interact with on the TOG stand. So definitely, I want to add a scoreboard to it. And maybe look at trying to improve the... you can see the autofocus keeps going in and out on the webcam, to look at doing something about that. And then obviously try and document the project, put it up somewhere if someone else wants to play with it or interact with it. So unfortunately you can't play the game now, because I can't have it taking over my living room all year round. But I have entered it in Maker Faire Rome. That's coming up in October. So I will be segregating my living room again. I'll be definitely adding some improvements between now and then. Sound effects and so on, to try and make the game a bit more interactive and fun. And looking to add a scoreboard to it, so people can know how well they're doing and see what score they get at the end. So do come back. Follow me on social media there, Jeffrey_Rowe, and you'll see me posting links in early October from the 8th to the 10th. So I'll have the game up and running for Maker Faire Rome, which part of it's happening remotely online, and some of it is happening in person in Rome. So thanks very much for listening, and sorry again about the audio trouble we had with Shane's talk. We have another talk coming up by Maya on her Core XY 3D printer. So if you give us a moment, I will get her all set up on Google Meet so she can begin her talk, and we'll be back in a moment. So I'm just great. And welcome back, everybody. Thanks for waiting. And sorry again about those technical gremlins we seem to be having tonight with audio clipping. But we are moving on to our. Before we move on to the last talk of the evening, be sure to put any questions you have about pizza ovens, LED displays, and any questions that come to your minds watching Maya's talk coming up next into the chat box, and we'll put them to all of our speakers tonight and get all your questions answered. So I'm going to hand you over now to Maya, and you are now live.
Okay. Hi, I'm Maya. I run Hackerspace.ie, but this is not a sales pitch, so I'm gonna make a little digression to what you were saying earlier, Jeffrey. This is a long tradition that after all the methods and ways failed, it's time to consult the manual, right? But getting back to the topic, I used to be a member of TOG for several years. I remember a talk to Zio. I think this even prior to my transition. I am probably most known from my boats over there, and at this thing, the Etcher lizards were 2 years ago on the Dublin Maker as a toy on the top stand. I couldn't be there, but at least this part was. But this talk is about printer and 3D printer and building a large one because sometimes you need to do something bigger than you and this one there could do. So I, of course, been looking for a while for the designs that were available on the market and on the 3D printing scene, the open source, and nothing was quite right for me. So I decided to build my own. And I kind of approach this from minimalistic point of view, not to over-engineer, and use the simplest set of hardware and gear to actually achieve. And I think my design is quite compact, and I'm just gonna switch to the other camera and give a broad view of this. And here is a Banshee for reference. And the basic design principle is, of course, the core XY kinematics on the top, and how this is pretty much standard besides the design of the element, which kind of looks nice and it's artistic. The difference from current designs is that it uses steel rods as it used to in hypercube design from several years ago. Now everything, all designs move to NGN rails, which are quite expensive and difficult to handle, really. So my approach was to actually use those and linear beams over there. And what is kind of modern in this printer is a kinematic bed holding 3 points, which allows pretty much all the angles to the bed and allow currently making sure that the bed is really flat and parallel to the plane of the printing head, and maybe in the future the non-planar printing. This of course needs support from the software, which is from slicers mostly, which is non-existent right now. But from the hardware there is a the octopus board, and here is a Raspberry Pi. This runs Clipper, and yeah, I'm just gonna do home. Okay, and now for the Z. The homing, and this is also different from the all designs. The homing procedure for the Z axis is going down. This way, if there would be, the bed was not parallel or skewed somehow bigger than it should be, it will flatten itself, and then for the procedure of flattening the bed, can rise up and just check. And this is the maximum speed which I am using right now. This is 350 millimeters per second. It doesn't look this fast because the bed is large, but on the smaller printer, this would be, yeah, it would be way too fast to handle. So yeah, now when the bed is high, I can zoom into to show you the rails. The rails are two rods, and here's a belt which is going back and forth, and it's doing a reduction 2:1, which allows a better resolution and also helps holding this bed. Because this bed is it weighs 5 kilograms. This is 8 millimeters aluminum plate, and here is a glass, which yeah, it's kind of heavy. I kind of made off, take a shortcut as soon as Ratrick made this bed available when they introduced their own VCore printer. I just got this bed and read. So there is a link to Onshape design. If someone is interested in details about this, I'm gonna switch back to the main screen. If someone is interested in how this looks in the details, check the link to Onshape. If someone is interested in making this, I can share my experience. I can help source the hardware. This is literally 10 rods, 10 linear bearings, 12 or 16 pulleys. Yeah, the empty one, and I think like 8 tooth. The bells are running on the 16 tooth pulleys. This is quite good for the max of the stepper motor, so the resolution is 100 steps per millimeter with the standard 1/16 micro stepping, which is kind of standard. As a balance between resolution and the torque, when you go more micro stepping, you are losing torque, and this needs you to slow down. And regarding the speeds, this is how this is the speeds that I am using currently. So the velocity 350 millimeters per second, acceleration 5,000, square corner velocity 20. Standard Voron does 300 3005. Of course, Pimp Twam does a magnitude faster with the acceleration, but the purpose of my printer was not breaking the speed bench records. And by the way, with this setup, yeah, this is 20-minute benching, and I literally can't go any faster because right now my hot end is a standard V6, which can't do more than 10 cubic millimeters per second, and this translates to the linear speed of 100 millimeters per second on 2.02 and 0.4 layer. Yeah, 0.2 layer height on 0.4 nozzle. Yeah, regarding the nozzle, I can show one more thing. Not this one, this one. So I made the nozzle detachable, and for the sake of quick tool change, this is quite simple idea. This locks on the linear bearing, and here on the top there are two magnets which registers against the top bearing. So it's like that. Yeah, and this is pretty much all for the sake of this printer. And yeah, if someone has any questions, I will be glad to answer. As the terms of price, this is of course it's gonna be more expensive than Ender. The bed alone costs 300 euros. The 100 for the aluminum plate, 60 for the glass, and 100 for the heater. This is a silicon heater from Kinovo, 1.2 kilowatts, AC main. So yeah, it should be cheaper than Radric, way cheaper than Voron, way less complicated than Voron. Literally every part, every element of this printer is 2 or 3 printed parts screwed together, few pulleys and belts, and that's it. There is no issue with the Z wobble because there are no screws that are skewing out the whole bed. The prints are quite good, even for the quite basic extrusion. And yeah, for now it's a Bowden setup. The Bowden tube is quite long. This is over a meter, so obviously stringing is an issue, but it's survivable. There is no much stringing, not what you would expect from the Bowden tube this big, and yeah, Clipper helps. The pressure advance. The pressure advances on this length of the tube, especially when you print fast, puts a lot of stress on the filament, and yeah, but the version with the direct extrusion is on the way, and soon I will be designing a hot end for the direct drive. I have a Sherpa Mini already, and just waiting for some high flow nozzle to arrive. And yeah, if someone needs a bigger printer, I can help with that. If someone needs a big print, I can help with that. This is 410 by 410 and 420, and yeah, that's it.
Thanks very much, Maya. And we're just going to switch everybody back to a slideshow while I set up the group Q&A. Make sure you stick your questions into the live chat there. So we're going to be putting them to our panel of speakers and answer any questions you might have on the talks. Be right back. And we're all on the screen. Welcome back, everybody. Thanks for all hanging around. I'm still sending video. Let me unclick that thing. Sorry about some of our technical issues we were having earlier, but I see people are still putting in questions, so we still have plenty of interested viewers. Anyway, so the first one is for Shane. Even though we didn't get the full talk, there's still questions coming in. And one comes from an eagle-eyed viewer from County Laois, my mother. She wants to know why it says Duro on one of the bricks, and is Shane based in the Midlands?
The irony, Jeff, is that you were breaking up for me there.
I'm breaking up for you now.
What I got from it was, why was I using Duro?
Yeah.
I heard gibberish too.
We had two options, Duro and a thigh for brick. What does he use? Just, yeah, they preferred Duro over a thigh. They were the option, and those bricks were difficult to come by.
Okay. Next question came in here is for Maya. The first one here is, does your 3D printer need a cover?
Can you repeat this, please?
Does your 3D printer need a cover?
Need a what?
A cover.
Well, making cabinet out of this is quite easy. You just screw several sheets of plywood or acrylic or whatever to the sides, and you just invent some kind of doors at the front. And yeah, for printing more complicated materials, it's like, ABS or it's definitely gonna help. But for now, as I'm printing only with PLA for now, it's kind of not needed.
Okay. Next question here coming in is, do you have any issues powering a large LED display, especially when there were a lot of LEDs on at the same time? So I didn't have a problem when I was just using the 16 by 16 array, But once I moved to the 32 by 32, it stopped working reliably most of the time. So I switched to a dedicated 5 volts, I think it was 3 amp power supply. So still on paper, it's underpowered if the LEDs were on 100% brightness. But using the library, I set the brightness much lower. So it seemed to work fine with the 3 amp 5 volts power supply. So I have another question, if my phone would be responsive. Another question in here about pizzas. Are the bricks bonded somehow to the cement slabs for improved thermal mass? If so, how? And if not, does it matter?
Depends which bricks. If it's the 5 bricks on the bottom, they're only held together around the edge. I think that you might have seen that, at least in the presentation. There was just a tiny little bit of concrete holding them in place. Underneath them is just sand. Between them is the powder when cutting those fire bricks. That's what's in between them. For the bricks in the arch, they're just stuck to the perlite concrete mix. There's no real sensible, or at least nothing beyond concrete that seals them together, and maybe there should be.
Okay. Next question in here is for Maya. Is how much noise does the printer make compared to other printers you have used in the past?
It's actually quiet. I am running those TNC 2130 drivers, and it's the rails. People say that they still are louder than the MGM rails, but no, I don't think they are. During the printing, I can compare it pretty much as the same noise as my Ender 2 was doing at the printing at 50. When I'm printing at 100, I'm doing moves 350, and it's more like kind of drumming, really. I could just run something for a while, and you could just check, but I'm not sure how it's going to translate into.
Yeah, I'm sure with the audio problems we've been having tonight, I'm not sure we can risk different noises and different soundscapes.
I'm actually surprised how quiet it is.
Okay. And would you leave it on overnight and go asleep?
I already did it.
Okay.
Like, this is the central part of the Rocinante model. It's scaled twice, and this is like a central, so it's gonna be like, one more on the top and 2 more on the bottom.
Wow.
This was like 6-hour print, and I literally fainted when I was like, this was already late night when I started this print, and I just let it run when I fall asleep. I haven't fainted, I fall asleep. But right, this is kind of risky because this is AC power, right? This bed is heavy. I'm kind of worried here because if the belt would snap, how this bed would fall, and there is nothing underneath, but theoretically you can imagine such kind of catastrophic event. It won't happen, most likely, but this is so you shouldn't really be leaving 3D printers on their own in general, right? You can, this can be a runaway heater anywhere. From the fire hazard point of view, the thermal runaway on the hot end is more dangerous.
Yeah.
Because it's already on the 200 and there's a lot of plastic around. and there is literally a path to the rest, filament and the bowden tube. There is a path where this fire can travel and go to something else. The bed, yeah, there is a thermal fuse on the bed, and I am not kind of worried about the bed, but I am trying not to touch this from the bottom because there is 240 volts underneath. So, like, of course, you need to be cautious. This is like, you could put the finger in the wrong place and you can get, smashed. At high speed, this has enough kinetic energy to actually do some damage. This is a device which is running and has its own program to pursue. So if it's run on something, it just smashes it. And the same with the heater. If the thermistor is gone, it's gonna keep heat. So at some point it can be fired.
Okay. So that's all the questions that we have for this evening. But before we go, I'll just go to each of our speakers and they can say where our viewers might be able to find more about your project or yourselves in general. So we'll start off with Shane. Where can people find you, Shane?
They can find me on Twitter. I would like to thank the guy who kind of inspired the project, Vincent Bradley. He's done a good video on YouTube. He's an Irish-based YouTuber that did a very similar build. So that would be a good place to start for sure. Any of the photos and techniques I've used, I've put up on Twitter as well.
Okay, thanks. And Maya, where can people find out about your projects and yourself?
Well, I put a Twitter handle to my shop, makershop.ie. I have a personal Twitter, but I usually rant there about trans rights and hypocrisy of diversity and inclusion in Ireland. So like this audience would be interested in that. The link to the project with this printer on the Onshape is I think in the materials that you already published, Jeffrey. If someone is interested, like in doing and creating community about this around this project and like taking it forward, we can do a Discord or whatever and go on with this. Like I was not bothering with writing any documentation because this is a project for myself right now. But if someone likes this design and finds it useful, I can share it. And I'm already sharing this on the Onshape.
All right. Well, thanks very much for giving us your time tonight. And if anyone's interested, we will twist Shane's arm to do a full recording of his talk, and we'll publish it on our YouTube account. Sorry again for all that clipping. So I'll just flip to me back on screen so I can just. And I've noticed I muted my mic. Thanks everybody for coming along tonight. Sorry again about the clipping noise. We're still trying to overcome some of these technical issues that we have. Shane will record his talk and we'll publish it on our YouTube channel so you can have it full and uninterrupted by technical issues that we've had. And just to say once again, we have just moved into TOG 4.0. It's a lovely space out in Kylemore. You can find out updates on our website. We also post videos here on our YouTube channel of different things we're doing in the space. And you can follow us along on our social media for updates on how the space is getting on. We're open for members. You can come along. We have different open evenings for new people to see the space while we're still doing the fit out. But we hope to soon have regular events back as soon as the health regulations allow it. So thanks for coming along again, and we'll see you at our next event.